All right, so the first thing we're going to start with in rational expressions, there's a couple of things. One is non-permissible values, right? And the other one is simplest form. So that's the two things we're looking at today. Any algebraic expression that can be expressed as the quotient of two polynomials is called a rational expression. In other words, rational expressions look just like fractions. Okay, so until now, you're used to working with fractions. Difference is that the numerator and the denominator can be polynomials instead of just numbers. So some examples of rational expressions. So a fraction like 7/3 is a rational expression. Okay, but other things are 3x over x minus 2, x squared minus 4 over 3. Anything with a polynomial. So it could be a binomial. It could be binomial, monomial. You could have two trinomials, trinomial divided by a trinomial. And more complicated ones here like x squared plus 6xy plus 5y squared and x squared minus 25y squared. So all of these are examples of rational expressions. All right, let's move on to non-permissible values. Rational expressions can be evaluated at different values of the variable. Okay? Now, if it's a fraction like 7/3, there's nothing to evaluate, that's 7/3. But when it's 3x over x minus 2, what's the value at x equals 4? What do we have to do? So where we see x, we're going to substitute in a 4, right? We're going to replace every x with a 4. 3 times 4 is 12. 4 minus 2 is 2. And that evaluates to give us a value of 6, okay? That particular expression. What is the value of 3x over x minus 2 when x equals 2? Okay, so we do the same thing, right? We substitute in a 2 everywhere we see an x. 3 times 2 is 6. 2 minus 2 is 0. That gives us 6 divided by 0. What's that equal to?
0.
No. Undefined. We can do 0 divided by 6. Right? 0 divided by 6 is 0. Yeah. But you cannot divide by 0. So division by 0 is undefined. And that means that when we are dealing with rational expressions, we have to be careful. Some rational expressions are not defined at particular values. In particular, rational expressions are not defined at any value that makes the denominator equal to 0. Since substituting 2 into 3x over x minus 2 causes the denominator to be 0, we say that 3x over x minus 2 is not defined at x equals 2, and that 2 is a non-permissible value of 3x over x minus 2. Right? In other words, you're not allowed to substitute a 2 into here because it would give you a 0 expression in the denominator. So a non-permissible value of a rational expression is any value that makes the denominator equal to 0. Okay. Any questions so far? To find non-permissible values of a rational expression, you must determine all the values that make the denominator equal to 0. Why is that? Looks a little cut off there. The task, well, it's on your sheet, right? It says equal to 0. And it says the task of finding non-permissible values can be asked in several ways. Okay? So we have several ways we can phrase this. For what values of the variable is each rational expression not defined or undefined? State the non-permissible values or state the restrictions. Okay? And anytime you're dealing with a rational expression, somewhere in the back of your mind you have to be thinking non-permissible values, restrictions, etc., right? That there are certain values that I have to watch out for. Okay, number 1. For each rational expression, determine the non-permissible value or values. Okay, there may be more than one. That is, determine the value of x that makes the denominator equal to 0. Where necessary, express all non-permissible values as improper fractions. Okay? So we like stuff to be exact. That's why we deal with fractions. That's why we use the quadratic formula to solve. We leave things as a rational or radical expression, right? So we like things exact. We don't like to round them off. And so that's why we're going to express as improper fractions. Okay, so the work involved here. The work is to say, well, I want to know the values of x that will make 5x equal to 0. Okay, what value of x? So what's x equal to? Okay, so x is 0 divided by 5, which is doable, right? You can divide 0 by a number. Okay, and then the non-permissible value, the value you're not allowed to have, so we say x cannot be equal to 0. All right? So when we're evaluating that expression, we could say, I can evaluate that expression for any value of x except when x is 0. Okay, next one, 5x over x plus 3. In this case, again, we're only interested in the denominator, right? We don't care about the numerator. So we'll say, well, the work is I want x plus 3 to be 0, which means that x is equal to negative 3, right? And so my non-permissible value, we say that x cannot be equal to negative 3. So when we state non-permissible values, it's always as a not equals. Next one. And if you want, you can kind of work your way through. Again, we're only interested in the denominator, right? I don't care if the numerator is 0, because I can go 0 divided by something. That's fine, right? No objections there. What I care about is I don't want x minus 1 to be 0, so I do not want x to be 1, so x cannot equal 1. Okay, that's the non-permissible value. Next one. 4x minus 3 equals 0. Remember, my work is to say that that's equal to 0, to solve the equation where that's equal to 0. So 4x is equal to 3, and x will be 3 over 4. And then the non-permissible value, we now state that as x cannot equal, right? So x is not equal to 3 over 4. Okay? Keep going. 3x plus 2. We're going to solve 3x plus 2 equals 0. So 3x is equal to negative 2, and x is negative 2/3. And we state our non-permissible value and say x cannot equal, is not equal to negative 2/3. Where this comes in ultimately is when we're solving equations. Right, we solve equations. Some of the methods we use to solve equations, as you found with absolute values, leads you to what we call extraneous solutions, right? It's a solution to the equation that you've made, but it's not a solution to the original equation. It needs to be rejected. And here, maybe we solve an equation, and it involved this term, and we say, oh, wait a sec, I got x is equal to 1, but x can't be 1. Okay, so then you need to reject solutions. So that's part of doing this non-permissible value. So here there will be two values, right? 6x minus 1 is equal to 0. 6x is 1, x is 1/6. And x plus 5 is equal to 0. X is equal to negative 5. And when we state our non-permissible values, we go x is not equal to 1/6 and negative 5. Okay, so we have those two, in this case, two values. We also have two values in this last one here, right? 2x cannot equal 0, which means that x cannot equal 0, or x equals 0, right? We're solving the equation 2x equals 0, which says x equals 0. And we're solving the equation 3x minus 7. So any expression in the denominator that has an x in it has to be equated to 0, solved, and then you state your non-permissible values. So in this case, the values of x that will give me a 0 are 0 and 7/3. So we say x cannot equal 0 or 7/3. Any questions on the first page? Or for you, what is the first page? All right, so we don't always want to have to solve that or necessarily show the work, right? So we want to get to the point where we can just look at it. So this says, by inspection, state the non-permissible values of each rational expression. Okay, what can't x be? X cannot be 0. What can't x be in the next one? Okay, x cannot be 0. What can't y be? 0. So if x is 0, the whole denominator will evaluate to 0. If y is 0, the whole denominator will evaluate to 0. Right? Any other values of x and y are fine for this, but they can't be 0, right? One of them can't be, or the other one can't be, or both of them can't be. Okay, how about this one? -4. Okay, next one? +5. Next one? -3/5. Okay, is there a trick to doing that?
Yeah.
What is it?
The one without the variable.
Yep.
Divided by the one with the variable.
Yeah.
And the negative of that.
Yeah.
So,
Okay, so what I do is I take the opposite sign of the number without the variable, right? So in this case, 3. So I make it -3 and then divide it by the one with the variable, right? Because basically what you're doing, you know, remember what we're doing is saying this, right? 5y plus 3 equals 0. So 5y is -3. So you're just changing the sign of the 3, right? And then you're dividing by 5. So y. Okay, so change the sign of this. What do we get? Okay, so 2/3, -1/5. Okay, down here.
0 and -1/6.
All right, so that's what we want to get to, the point where we can just state the non-permissible values by inspection, not having to solve, right? But if you need to solve it, then by all means, you know, take a piece of scrap paper and solve each one separately and state the non-permissible.
Why is the third one from the bottom up? It says y equals -3/5. Yeah.
There you go. Better?
Yeah.
Good catch. Yeah, so it should say y is not equal. So all of our non-permissible values are stating the value the variable cannot have, right? It cannot be these particular values. Write a rational expression with the following non-permissible values. So let's turn this around. I'm going to give you a non-permissible value. I want an expression. So what would a simple expression be for this one?
So x.
And how about just 1/x? Right? If x can't be 0, then the denominator has to have an x by itself. Right? Can't do something with it. If t cannot be 5, then what's a simple expression here? Yeah, so simple 1/t minus 5. You could also have, you know, or t plus 7/t minus 5.
Doesn't really matter what you have on top.
Doesn't really matter what you have up top. As long as you don't put a 0 up top, right? You can't do 0 over. If y is not equal to -3/4.
1 or y plus 3.
Okay, so remember what we're going to do is back this out. Now this time we've got to change the sign on this, put this number by itself, and put this number with the variable. Okay, so think of it this way, right? Think of it as y equals -3/4. So 4y equals -3, and 4y plus 3 is equal to 0. So that's what I want, is 4y plus 3 down there. Okay, so you need to be able to work your way forwards and backwards. Okay, what about a 5 and a negative 2?
X plus 2.
Okay, so let's go like 7x minus 12 over x minus 5 and x plus 2. Okay, again, numerator doesn't matter, right? You can put anything you want in the numerator. It's the denominator would have to have an x minus 5 and an x plus 2. Okay, last one. So we go with 3m minus 1 over, what's going to be here?
2x. Or 1 over x, and then...
There's no x's in here.
Oh, sorry. Well, it said 0 right there.
It says m cannot be 0.
Okay, not be 0.
So I'm going to put an m down here by itself. Right? That's the m can't be 0. Now m can't be 4. So what am I going to write? M minus 4, because if I make m 4, this expression will be 0, and m can't be 1/3. 3m plus 1. Okay, so again, just verify these. So we're just going to take the opposite sign. We'll take negative 1 over 3, 4, and 0.
For m cannot equal 0, could we put 2m in the front?
Sure, you can put any number you want in front. Just so long as there is a single factor of m, right? Because that's the one that can't be 0. There is an m minus 4, and there's a 3m plus 1. Okay, questions on this page? None? Moving on. Simplifying rational expressions. So this is at the bottom of your page. All right, so the first step really was, what is a rational expression? We know it's something that's written in the form of a fraction, but you could think of it as an algebraic fraction because the numerator and denominator can be polynomials. Since there are variables in the denominator, we have to be careful that the values of those variables will not make the expression equal to 0 in the denominator. Those are our non-permissible values. Okay? So non-permissible values stays with us for this entire unit, right? And all of next year when you do anything. It just stays with you whenever you see a rational expression. You need to be thinking, hey, there's values of that variable that will cause the denominator to be 0, which means this expression will not be able to be evaluated, and I just need to be aware of that. Maybe I need to state them explicitly. You will on the quiz on Friday, for sure, right? Because that's part of it. But it's just something I also need to keep in mind, because when I start solving equations, I need to be able to look back and say, oh wait, that solution to the equation is one of the non-permissible values, and so I need to reject it as extraneous, right? All right, fractions come in many equivalent forms. 10 over 20 is the same as 4 over 8, or 3 over 6, or 5 over 10, or 1 over 2. For this set of equivalent fractions, we say that 1 over 2 is the fraction in its simplest form, since it's reduced to lowest terms. Likewise, rational expressions that appear to be different may in fact be equivalent. Okay? And part of this just means, maybe you're answering a multiple choice question and you've got an answer, but you don't see it as any of the choices. You may have to simplify it. Okay? You may have an equivalent expression. To simplify a fraction, we divide the numerator and denominator by their greatest common factor. For example, 10 over 20, we're going to divide both sides by 10, giving us 1 over 2. 24, x squared y cubed over 18, x to the 5th y. We want the greatest common factor. What's the biggest number? So here, in essence, with the 10 over 20, we factored it, right, to say, what's the biggest number that goes into 10 and 20? Which you say 10. Okay, so I'm going to write the top as 10 times 1. And I'm going to write the bottom as 10 times 2. And then I can cancel the 10s. Here, we say the greatest common factor, well, the biggest number that goes into 24 and 18 is 6. When we're looking, they both have x's. We go for the lowest power, okay, the lowest power of x. You can't pull an x to the 5th out of this. You can only pull an x squared out. So we don't want to pull anything higher than x squared out of the bottom. And then we've got y cubed and y, so we only pull the lowest power, which is the y. We factor these. We get to cross these off. We get 4y squared over 3x cubed. Okay? Now, here we have to keep in mind that our non-permissible values are x can't be 0 and y can't be 0. In this expression, it's only the x that can't be 0. But when we state non-permissible values, it's always for the original expression, not the simplified form. Okay? So when we simplify, one of our steps is state the non-permissible values before you cross anything off, top and bottom. Okay? And I think that's it for that. Okay, in the table below, each row contains a rational expression that is not in simplified form. Express each rational expression in its factored form and then in its simplified form. The first has been done for you. Okay, so the first step that we want to do when we're doing anything with rational expressions is to factor them. Okay, so we have to factor first. So if we look up here, we get 5x minus 10, so the common factor is a 5, and you just get x minus 2. Now, here's the thing about factoring these guys. You can assume a lot of the time, 90% of the time, things are going to cancel off, right? The simplified form will be that I can cancel this x minus 2 top and bottom. So when you factor this and get the x minus 2, you can almost assume that one of the factors of this is probably x minus 2. Okay? It's a good starting point. It's not a guarantee, but it's a good starting point to say, hey, you know, maybe one of these factors is x minus 2 because it'll simplify if it is. But before we do any simplification, we must look at this and state the non-permissible values. So 3 over 2 and 2. All right, so your first step is to factor it. Your second step is to state the non-permissible values from the factored form. And your third step is to then divide out any common factors. So the common factor here is the x minus 2. That cancels top and bottom. We end up with 5 over 2x minus 3. So what that says is that this and this are equivalent. They will evaluate to the same value for any value of x except what? 3 over 2 and 2, right? And I can put a 2 in here and get a perfectly good number, right? Because it'll be 5 over 4 minus 3, which is 1. It'll just be 5. But I can't put the 2 in here or here. It won't evaluate, right? I'll end up trying to divide by 0. So these expressions are equivalent, this and this, for every value of x except for 3/2 and 2. Right? And that's not obvious here, so that's why we take the non-permissible values from the factored form. Because if I stick a 2 in here, I'll end up with a 0 in the denominator. If I put a 2 in here, I just end up with 5. Okay? So we can't do that. We can't say that they're the same for every value of x. We can say they're the same for all values of x except for these two. So let's try it. Let's just say we make x 0. If I make x 0, I'm going to get negative 10 over 6. Right? 0 will just take out anything with an x. Get negative 10 over 6, which is negative 5/3, right? If I put a 0 in here, I get 5 over negative 3, which is negative 5/3. Okay? So they'll evaluate. If I put a 1 in for x, I'll get 5 minus 10, which is negative 5. I'll get 2 minus 7, which is negative 5, plus 6, which is 1. So putting in 1 in for x, this expression evaluates to negative 5 over 1, which is negative 5. Put a 1 in for x, we get 5 over negative 1, which is negative 5. Right? So this is the simplified form. I can get every value that I would get out of this expression by plugging into this expression, which is a lot simpler. Right? It's a lot easier to work it out here than it is to work it out over there. Two provides, right? Two conditions, right? The x values that I evaluate cannot be 3 over 2 or 2. Okay, those are non-permissible. All right, let's work our way through a bunch. So, what I would do is say, all right, let's factor the simplest of these two. Which one's easier to factor, top or bottom? Top. Okay. What is the factorization? Now, what do you do every time you factor something? You check it, right? So we get x squared plus 2x minus 3x will be minus 1x minus 6. Okay, good factorization. Now, if we look at this and we say, okay, this isn't just factoring, right? It's not the factoring unit, so it's not just factoring. This is simplifying rational expressions. So it's likely that one of these two factors will appear in the denominator. Which one?
X minus 3.
Yeah, because it can't be x plus 2, right? If I put an x plus 2 down here, there's no way I get x squared minus 4x plus 3. I can't multiply it by anything to give me that. If I put an x minus 3, so I call this factoring without factoring. If I put an x minus 3, then what the other factor, to get x squared, I need an x. To get a plus 3, I'm going to need a minus 1. Now, did I factor that expression? No. I just said if it factors and if x minus 3 is one of the factors, then this is the other factor. But let's test it out. X squared minus 1x minus 3 is minus 4x plus 3. Okay? So it worked, right? And you can use that little kind of shortcut, or the idea simply being, since this is rational expressions, the questions are set up so that they should simplify, which means that one of the factors in the denominator should be one of the factors in the numerator, right? So you can either just straight factor this, just ignore the top, just straight factor. It's not really a hard thing to factor, right? X squared minus 4x plus 3. So you can just straight factor it, and then next step, non-permissible values. What can't x be? Can't be 3, can't be 1, right? Okay, and the simplified form, what do we get? So we cancel the x minus 3's, right? And we end up with x plus 2 over x minus 1. So again, what are we saying? We're saying that this expression, x squared minus x minus 6 over x squared minus 4x plus 3, is the same as x plus 2 over x minus 1. For every value of x, except x cannot be 1 or 3, right? Here you could put a 3 in there, it's fine, right? But if you put a 3 in here, it'll work out to undefined. Okay? So we're always interested in the non-permissible values for the original expression, not the simplified one. And that's why we factor, then we state non-permissible values. Right? That's easy to find from factored form. It's not easy to look at x squared minus 4x plus 3 and be able to state non-permissible values. Right? It is easy to look at x minus 3 times x minus 1 and be able to state the non-permissible values. And same deal, right? So if I put a 0 in here, I'll get negative 6 over 3, which is negative 2. If I put a 0 in here, I get 2 over negative 1, which is negative 2. Okay? So these two expressions will evaluate for any value of x. Will give you the exact same value, and this is much easier to work out than that one is. Okay, keep going. Factor the top. There's nothing to factor, right? 5x squared is just 5x squared. On the bottom, it's just x times x plus 3. What are the non-permissible values? Negative 3 and 0. Okay, and what is the simplified form?
X squared over x.
Nope. 5x. This x will cancel into this x squared. So 5x over x plus 3. Okay, keep going. What's the factored form of 6x minus 3? 3 and 2x minus 1. This is the difference of squares. Factors pretty. It's 2x plus 1, 2x minus 1. I could have guessed that one of the factors was 2x minus 1, so I could get some cancellation. But, you know, at the same time, it's 2x plus 1, 2x minus 1. What can't x be? Can't be negative a half, can't be positive a half, so we'll call it x cannot be plus or minus 1/2. And the simplified form? Yeah, 3 over 2x plus 1. Okay, keep going. What's the factorization of negative 6x squared minus 4x? Okay, so the biggest number that goes into 6 and 4 is 2. And they both have at least an x, so I'll take the lower power of x. I'm going to take the negative out of there while I'm at it, so I'll call it negative 2x. Okay, what does that give me? 3x plus 2, right? Again, negative 6x squared minus 4x. Okay, I'm going to assume that 3x plus 2 is a factor down here. If it is, then the other factor has to be an x to give me 3x squared, and with a plus 2, how do I get minus 6? Minus 3. Okay, I didn't actually factor that, right? I simply said if 3x plus 2 is a factor, then this is the other factor, because the 3x and the x give me the 3x squared, and to get minus 6, I'll need 2 times negative 3. Now I better check it. 3x squared minus 9x plus 2x is minus 7x minus 6. Okay, so it does check. Next step, non-permissible values. So what are they? Okay, so negative 2/3. Again, we're just doing this by inspection now, right? Looking at it and saying, well, okay, got 3x plus 2. Opposite sign be negative 2 divided by 3. And then 3. Simplified form. Negative 2x. And x minus 3. All right? So your first step in any of this is to factor. All right, the easiest thing to factor in this one will be the denominator, right? Okay, what's the greatest common factor that goes into 8 and 20? 4. And then we'll go with the smallest power of x, right? So it'll be 4x squared. So how am I going to get 8x cubed? 2x. And how do I get minus 20x squared? Minus 5. Okay, check it out, right? 8x cubed minus 20x squared. Okay, so what do I think one of the factors of this is? 2x minus 5. So what's the other factor going to be? X plus 3. Okay, let's check it out. 2x squared plus 6x minus 5x is plus 1x minus 15. Nice. Hey, we saved a little bit of work on having to do the factoring. Non-permissible values. 0. Okay, anytime you see an x by itself, right, or x squared, whatever, but just the x alone, then x can't be 0. And what's the other one? 5 over 2. And what's the equivalent, what's the simplified form? Yeah, x plus 3 over 4x squared. Okay, so the whole idea in rational expression so far is to get it into its simplest form, keeping track of the non-permissible values while we do so. So there's 3 steps to convert a non-simplified rational expression into its equivalent simplified form. The instructions you see will be simplified. The result will be an equivalent expression. It will not be a value. You cannot solve this, right? You can't at the end then come out and say x equals 7, right? Doesn't make any sense because the expression was never equal to anything, so x can't be 7, right? All we can do is find a simplified form. So your first step is factor, right? Factor fully the numerator and denominator. What's the second step? Once it's factored. Learn this one. State the non-permissible values. Okay, sometimes abbreviated as NPV or NPVs. Right? So the first step is to factor it fully. The second step is look at the denominator and figure out what value of x will make each of those factors equal to 0. Those are your non-permissible values. And then the last thing to do is, yeah, so divide numerator and denominator. Numerator and denominator by all common factors. Okay, and there's a question on the test we need to talk about at a future date about how to simplify a particular type of expression that, you know, a large number of people had some difficulties with. Okay, so we're going to go through number 5. We're going to simplify each of the following rational expressions. We're going to state the values of x for which the rational expression is not defined. That is, state the non-permissible values. Now, sometimes on a quiz we won't ask for non-permissible values, so you don't need to state them, right? Like not for marks. Sometimes we will ask for them, so you do need to state them for marks. If you're solving equations, you should know what they are. Even if you don't explicitly state them, you need to be aware of what they are. So regardless of whether we specifically ask you to state them or not, you still need to be aware of them, especially when you're solving equations, because you may need to reject solutions to equations based on the non-permissible values. Just say, hey, I can't have x be 2, and I solve this and it says x is 2. But my second step I did when solving this was to find the non-permissible values. Okay, can I factor anything here? No, nothing to factor. So then the next step is to state non-permissible values. So what can't m be? 0. What can't n be? Okay, if I'm going to write this, now, you know, I don't really need to write this in factored form, but I will. I don't need to. I could just cancel it down, but I can write it. So I'll say, well, I'm going to take the negative and the 6, because 6 goes into 6 and into 48. I'm going to take the smallest power. They both share an m. The smallest power of m that's out there is m. And the smallest power of n that's out there is n squared. And so this needs to be multiplied by m squared. I can factor this as 6mn squared, so that these factors are equivalent, except one's going to give me the minus. So, you know what? Maybe I'll leave the minus in here. So we'll go minus m squared. Okay, to get 48, I need an 8. I've already got the m, and I'm going to need what? N, what power? Cubed. Okay, I've already stated my non-permissible values. And so my simplified form is negative m squared over 8n cubed. Yep. Another way you can do this, you just cross off the m up here and take out the m cubed, leaving an m squared. Cross off the n squared, that'll leave an n cubed down beneath. Take out the negative 6, giving you negative 1. Divide that by 6, you get the 8, and you get negative m squared over 8n cubed. Okay? So you don't really need to factor that one. You can simply just, basically cancel it down in place. Most expressions won't be like that, though. Okay, next one, about as easy as they get. Right, we're factoring 3 bracket x minus 2, 5 bracket x minus 2. What's the non-permissible value?
Maybe
2. Nothing wrong with 0. You put a 0 in there, 0 is fine. Put a 0 in there, you get negative 6 over negative 10. So what, right? That's negative 3/5. Works very nicely. Right. It's not x being 0, right? It's 5x minus 10 being 0 that you're worried about. Okay, not x. Who cares if x is 0? So as long as x is not 2, these expressions are equivalent. 3x minus 6 over 5x minus 10 is equal to 3/5. Okay? If x is 2, they're no longer equivalent. Right? Because this is undefined, this is still 3/5. But you put x as 30 into here, you get 90 minus 6, which is 84, over 140. It's going to reduce to 3/5. Okay, let's pick an easier number. You put x as 0, you get negative 6 over negative 10, which is 3/5. Okay, x minus 3 over x squared plus x minus 12. So the first... Now, what we do is we put equal signs underneath, right? Because I'm saying this expression is now equal to, I'm going to leave that as x minus 3. I'm going to bet that x minus 3 is a factor, in which case the other one is x plus 4. Okay, so at this point, I don't care how you factor, right? You simply need to be able to factor correctly. You need to check to make sure your factorization is correct. Otherwise, everything goes wrong from there. And in this, it goes wrong, so what? Right? I mean, because nothing much happens from this. When you're solving equations that are taking you 6 lines of work and you make a mistake in the first factorization, then it all goes to heck, right? And all of a sudden you end up with huge expansions. You need to turn your paper sideways in order to fit them in, because and then you've got x to the 4ths and x cubes and all that. And you start saying to yourself, there was never anything like this in the homework, which is a true statement. There never would have been anything like that. And I think maybe I messed up, which is also a true statement. And you stop. At this point, you cut your losses. You stop, you go on and you do other questions, and you come back later. And you say, okay, when I come back to this, I really need to check my factorization because I think something should have simplified that didn't. And that's why I've got this horrendously large expression with all kinds of things floating around, right? So you really need to check your factorizations. You really want to do this set of homework perfectly. Because if you can't, then when you move into the next set, you still retain that getting the factorizations done perfectly. Because if they're not, then it gets ugly. Okay? So check it out. X squared plus 4 minus 3 is plus 1 minus 12. Okay? All the signs are correct. Everything's good. Got to state non-permissible values. 3 and negative 4. Okay? Cross off. 1 over x plus 4. So when the x minus 3's cross off, right, they get replaced by 1s. Right? Otherwise it just becomes blank over x plus 4. That doesn't happen, right? So it's 1 over x plus 4. Okay? So if you're dividing top and bottom by the same thing and there's nothing left up top, yeah, there is. It's a 1. Okay? There'll be a 1 left up top. Any questions on ABC? Seeing none. Let's move on. DEF. Factor the numerator and denominator, right? Numerator is easy to factor. What is it?
X minus 4.
Yeah, 2 and x minus 4. Okay, so what? Well, I bet that x minus 4 is a factor, and then to get a minus 8, I'm going to put a plus 2. Okay, I didn't factor that, right? Not in the slightest. I just said, I'll bet this is a factor, so I'm going to write it down, and then to get that negative 8, I need a plus 2 here. So x squared plus 2x minus 4x will be minus 2x minus 8. Okay? So if you get one factor right, it can help you in simplifying the expression, right? Because usually there's stuff that simplifies. Okay, let's state our non-permissible values at this point. What are they? Okay, -2 and 4. So first step, factor. Second step, state non-permissible values. Third step, cancel off. Okay, the common factors simplify. You get 2 over x plus 2. Those are equivalent. How do you know? What can you do? How can you know these are equivalent? What's a way that you can verify that without, putting a bunch of numbers in? But first, a question.
Oh yeah. Can you reduce that?
Nope. You can try, but anything you do would be wrong. So what kids now want to do is say, oh, but I can cross off the 2's. No, you can't. And if you think you can, and it's okay to think that. It's just, you can't act on it, is all. You can think it. But here's what you do if you think that, right? And a lot of you guys are thinking that, right? Looking at that and saying, I can just cross the 2's off. Okay, so fine. If you did that, what would you end up with? So if you cross, you'd end up with like 1 over x plus 1, right? Something like that. Like you're going to get another expression. Easy. Stick a value in then. So let's say you think that this becomes this. Okay, fine. If x is 2, I get 2 over 4, which is a half. If x is 2, I get 1 over 3. Well, they're not the same. So this is not an equivalent expression to that. So you can't do that. Now, if you try it and it does work out the same, then try another few values, okay? Don't be satisfied with 1. You may just have picked the one number that makes those two expressions the same, okay, when they really aren't. So you got to try a few values. If you try 3 or 4 values and you're getting the same expression each time, then that's called inductive reasoning, and you've inductively reasoned that probably these are the same. Like how much proof do I need? I'd have to try a billion more numbers, but I'm pretty sure these are probably equivalent expressions, since if I put in values that aren't the non-permissible value. Okay, so how do I know these two are the same? You can graph them. Graph this. y1 is 2x minus 8, bracket 2x minus 8 divided by bracket x squared minus 2x minus 8. Graph this as y2. If you see the same curve, you'll see the calculator drawing out the first curve. If you then see a little blinking cursor in the upper right of your display, then it's drawing the second curve. And if you don't see anything different being drawn, then it's drawing one curve on top of the other. That should tell you that, oh, okay, these expressions are equivalent, right? Likely. Okay, not a guarantee, but likely. I'm just going to move these guys up here. Okay, next one. What's easiest to factor, top or bottom? Bottom, right? Okay, so what's the factorization of the bottom?
2x plus 4y and 2x minus 5.
Yeah, so you recognize the bottom as a difference of squares. And you say it's 2x plus 5y, 2x minus 5y. Now, likely one of those will be a factor of the top. Which one? It's got to be the plus, right? Because if I put the minus in, then there's going to be a minus somewhere. Either they both are minuses, in which case that makes that a plus, but then this would end up being a minus. So the only possibility, if they share a common factor, which would be x plus y. Okay, now what are you going to do? You're going to check it out. 2x squared plus 2xy plus 5xy gives me plus 7xy plus 5y squared. Check. I'm not going to check the bottom because it's a difference of squares. I know I factored it correctly, right? I mean, you shouldn't need to expand a difference of squares to know, because there's only 2 terms. But you could do it. 4x squared minus 10xy plus 10xy, 0xy, minus 25y squared. Okay? Now, what are my non-permissible values? This becomes a little more difficult. Yeah, negative 5y over 2, right? You just say, okay,
So it's plus or minus.
x cannot equal plus or minus negative 5y over 2. We just take this expression, the 5y, change its sign, make it negative 5y, divide it by 2, get negative 5y over 2. We do that here, change its sign, becomes plus 5y divided by 2, so we just say plus or minus 5y. I don't need a negative on there. So x cannot be equal to plus or minus 5y over 2. These are points on a line, right? There's more than one point that makes that true. Okay? So if by some chance, and we're not going to ask you to do it, but if by some chance you had to solve an equation that involved that, you would then have to make sure that you rejected any solutions where that was true. Okay? That will not be asked of you in this course. Okay? Or in high school, really, I don't think. Okay. But future math beyond this, you may have to keep in mind, right, just the idea. You need that idea of rational expressions have expressions in the denominator. These cannot be equal to 0. It's not permitted, and just something I got to keep in mind. Okay, simplify. Let's throw an equal sign there to say this is equal to this, and ultimately it's equal to x plus y over 2x minus 5y. Okay, questions on D and E? I mean, F looks, yeah.
Can, do we have to put non-permissible values for what y can't equal?
No, one or the other. You don't need both. Okay. I mean, y can't equal plus or minus 2x over 5, right? You just multiply both sides by 2/5. Right. That would make, that's reciprocal of this, make that a 1, and then it would make that a, no. Okay. So in cases where there are two variables, you only need to express your non-permissible values in terms of one of them can't be, and then something with the other. Okay, equals what? Okay, now in this case, x plus 5 is not a factor of the denominator, right? I can see that. So how do I factor the denominator?
X plus 2.
Okay, what are my non-permissible values?
0 and negative 2.
Right, 0 and negative 2. I'm just writing them up here because, you know, there's room. And how does this simplify? Two, right. Sorry. Okay, so that defied the rule, it broke the law. It's unexpected, but I thought something, you know, nothing really much canceled. Okay, nothing really much canceled. You know, we managed to take a 3 over 6 down to a 1 over 2, right? But only because the 3 and the 6 were factors. I can't look at this 3 and 6 and just cancel them, right? Say, you know, that's a 1, that's a 2. You can't do that. That is not correct, right? They have to be factors if you want to. Okay, questions on D, E, F? Nope, let's do the last two then. G and H. Oh, sorry. G and H and then number 6, and then we'll be done. Although we kind of already did number 6. Okay, just let me know when you're ready. Good? All right. Okay, so what's the common factor in the top? 5x. X plus 2. Likely there's an x plus 2. And if there is, it's going to be 3x minus 1, right? Because to get that 3x squared, I'm going to need a 3x with the x. And to get the minus 2. But I'm not sure this is. I'm going to check it out. 3x squared plus 6 minus 1 is plus 5 minus 2. Okay, so that's good. Let's throw an equal sign on the front of the line. Because this expression is equal to this expression. Okay, let's state the non-permissible values. One-third, negative 2, and then let's simplify. So anything that simplifies should end up with, here's my original expression, equals my factored intermediate form, then I state the non-permissible values, and then equals, and now I cross off, or literally, or not, you know, figuratively, if not literally, cross off the common factors, and write down the expression. What's easier to factor, 9 minus x squared or 2x squared plus x minus 21? Nine minus x squared is a difference of squares. You have to recognize that. You also must be spatially aware of what's behind you, but you have to recognize that 9 minus x squared is a difference of squares, right? So you can factor it. 3 plus x, 3 minus x. Now, you know, I got a plus and a minus here. I don't know if one of these and one of those is not written, so let's just factor 2x squared plus x. Okay, 2x, x, minus 21. Well, it's got to be 7 and 3, right?
Yeah.
So it's got to be plus 7 and minus 3. Gives me 2x squared minus 6x plus 7x to give me plus 1x minus 21. Okay? Now from here, we do non-permissible values. And then as Ryan said, but they're not the same, but they're kind of almost the same. But so x cannot be 3 or negative 7 halves. And we look and we say, they're almost the same. I got x minus 3. I got 3 minus x. You know, they're the same, only the signs are opposite. Right? This has positive 3, negative x. This has positive x, negative 3. So here's what we're going to do. We are going to factor a negative 1 out of the top. And I don't need to write the 1. I'm just going to put negative. And I'm going to change this from 3 minus x to x minus 3. Now note, this gives me negative x plus 3. So it gives me this, right? And the 3 plus x is just going to stay the same. Or let's write it as x plus 3, really, because we tend to write them that way anyways. Okay, so all of you need to look at that and say, yeah, okay, I'm good so far, I see what you've done. Okay, what we did, we wrote a negative sign up top. We changed 3 minus x into x minus 3. If I take that negative and multiply it through, I'll get negative x plus 3 or 3 minus x. The x plus 3 or 3 plus x, those are the same either way. There's no change there. Now on the bottom, I've got my 2x plus 7, and I've got my x minus 3. These guys are the same, so they cancel, leaving me with negative x plus 3 over 2x plus 7, okay? Which I'm just going to write this way. And you wouldn't be wrong if you wrote negative x minus 3 over 2x plus 7. It would be equivalent. Okay? Just keeping in mind my non-permissible values, right? They extend all the way through, right? That's always true. Those are the non-permissible values. Okay? So that's a trick you're going to run into sometimes where you're looking at it and you're saying, you know, these guys, like, they're almost the same, but not quite. But if I make this negative, I'll get a negative 3 and a positive x, and then they will be the same. So I'm going to write this, I'm going to factor a negative 1 out of this, and that allows me to change the signs. And now these guys are the same. Okay? So yes, you have to do that if that's the case, right? If it happens that you're looking at it and you go, hey, they're almost the same. Oh wait, yeah, I remember that trick. Factor negative 1, and then away we go. Okay, last one. State a rational expression with the following non-permissible values. This is what we did. We did this already, right? So, and this should be pretty easy. So this one, well, how about 1 over x minus 3? This one, how about 2x squared minus 12x plus 17 over, because this is what matters, the numerator doesn't matter, what goes down here? 4x plus 1, right? This is anything. I could have written that as a 1. Okay, so it doesn't matter what I wrote in the numerator. You know, keep life simple. You get this on a test, stick a 1 up top, and then you don't have to worry, right? You say, you know, but I won't be looking at your top. Unless you stick a 0 up top, and then I'll be looking at that. And the last one, what let's do the denominator first. What can't I have? Or what am I going to put in here? X. Okay, so change the sign. This gives me 7 over 3. That gives me the 0. What would you like up top? 3. Okay, could be 3x. Could be 3x squared. Okay. Doesn't matter. Okay. It's anything you want it to be.